All right, let's get right into it. In the world of AI, we've all kind of gotten used to one simple rule. Bigger is better, right? More data, more power, bigger models. But every once in a while, something comes along that just completely flips the script. And today, we're diving into a classic underdog story from the world of open source AI. So just take a look at this. On the left, you've got WebSailor-V2, an AI model with about 30 billion parameters. And on the right, that's DeepSeek V3.1, a monster with 671 billion parameters. We're talking more than 20 times larger. And yet, when you put them head-to-head on one of the toughest web research tests out there, the smaller model doesn't just hang in there, it wins. And not by a little bit either. So yeah, that brings us to the big question, the one we're going to unpack here. How on earth is this possible? How does David beat Goliath in the AI agent arena? Well, the answer is fascinating, and it points to a huge shift in how we should be thinking about building these intelligent systems. To really get the how, we've got to first understand the why. See, there's this massive performance gap, a chasm really, between the two main camps of AI agents out there. On one side, you have the big guys, the proprietary closed-source agents from the giant tech labs. They're insanely powerful, but how they're built, what data they use, it's all a black box. On the other side, you've got the open-source agents. They're transparent, they're accessible to everybody, but honestly, they've been struggling to keep up. And this performance gap has become a real bottleneck, slowing down progress for the entire community. The team behind WebSailor-V2 figured that trying to close this gap by just building another giant model wasn't the answer. Instead, they focused on solving two fundamental problems: the quality of the data the AI learns from, and the environment it's trained in. So let's dig into their first secret, which is all about the data. Think about it. You can't build a brilliant researcher by just having it read kids' books. You've got to give it really complex, tricky puzzles to solve. Now, the old way of creating training data was pretty straightforward. You'd start with a simple question and then just branch out step by step. It creates these neat, clean, tree-like paths. It's kind of like building a simple family tree. But let's be real. The world isn't a simple family tree. It's a messy, tangled, interconnected web. So the new approach is totally different. Instead of a family tree, I want you to picture a detective's clue board. You know, with all the photos and newspaper clippings and strings connecting everything to everything else. This new dataset, SailorFog QA V2, is designed to be that messy web. It intentionally creates dense, overlapping connections that much more accurately reflect how knowledge actually works in the real world. And they didn't just stop there. They made the puzzles themselves way harder. So instead of just hiding a name or a date, that's a simple trick called obfuscation, they introduced all sorts of different uncertainties. This forces the AI to go way beyond basic keyword searching and actually develop the kind of sophisticated multi-step reasoning skills that a real human expert would use. Okay, so you have this brilliant, complex data, but how do you train the AI on it without it taking forever and costing a fortune? Well, that brings us to their second big secret. They built what is essentially an AI flight simulator. See, training an AI on the live internet is super slow and incredibly expensive. So the team built this clever two-stage system. First, the AI gets to practice in a simulator, which is an offline copy of Wikipedia where it can learn the ropes quickly and cheaply. It can make mistakes, it can experiment, it's all good. Then, once it's ready, it graduates to the real world with live web tools. This creates this awesome feedback loop where the better data improves the AI, and the smarter AI, in turn, helps generate even better data. So, what kind of problem does all this smart training prepare the AI for? Well, get a load of this. This is a real question from that BrowseComp benchmark. It's a total needle-in-a-haystack problem, buried somewhere under layers of financial reports, legal documents, and decade-old press releases. Now, solving this isn't about just one lucky Google search. The actual solution path took the AI 29 separate, distinct steps of reasoning and using its tools. So how in the world does it think its way through a maze like this one? It basically acts like an expert human researcher. First, it deconstructs that messy paragraph into a simple checklist of facts it needs to verify. After a few early searches go nowhere, it pivots. It realizes the most unique, findable piece of information is that bit about a founder changing roles back in 2008. That becomes its golden clue. It uses that clue to find a likely company, in this case, FormFactor Inc. But, and this is the crucial part, it doesn't stop there. It then goes back to its original checklist and systematically verifies every single other clue against that one company. And only when everything checks out does it finally put together the final correct answer. So this powerful combination, smarter data and a much smarter training environment, that's the whole secret. And the payoff? Well, the payoff is what we saw right at the beginning, a massive leap in performance that starts to finally close that big gap. I mean, just look at the numbers again. Across multiple incredibly difficult benchmarks from web browsing to things called HLE and Gaia, WebSailor-V2, the 30 billion parameter model, is consistently outperforming the 671 billion parameter giant. It's not even close on some of them. That score, 35.3, that is the new state-of-the-art for open-source agents on what folks at OpenAI have called one of the most challenging benchmarks ever made for these web agents. This is a huge, huge milestone for the whole open-source community. But here's where it gets really wild. This isn't just about an open-source model beating another open-source model. On this other benchmark, DeepResearch, look who WebSailor-V2 is running with. It is right there, neck and neck with the absolute best proprietary systems in the world, like Google's Gemini and OpenAI's own model. It's not just closing the gap anymore, it has leaped right across it. And really, it all comes down to what the researchers themselves said. Their key takeaway was that high-quality data and a stable training environment are more critical than the specific algorithm itself. In other words, it's not just about the size of the brain, it's about the quality of the education. And all of this leaves us with a really provocative final thought. This result hints at a major shift in the AI arms race. Maybe, just maybe, the future isn't this endless quest for bigger and bigger and bigger models. Maybe it's a race to develop smarter, more efficient, and more creative ways to teach them. Perhaps the next big breakthrough won't come from more silicon, but from better simulators and much, much smarter curricula.